All right, ladies and gentlemen, today we're going to talk about common logarithms, which are actually going to be very prominent in the rest of our chapter. So common logs are, I like them. They make sense to me. They hopefully will make sense to you as well. So first two definitions. If we just have a logarithm, we abbreviate this. We call it the log of x. Those are the same thing. So to the base 10. So if we would write it like this, log 10, and your base is always a subscript, so it's smaller. And then your x would go right here. So this says log base 10 of x is y. So this is true if and only if we can rewrite it like this. So you take 10 to the y power equals your x. So I like to think of it as this guy just getting squeezed in here, and then everything kind of goes up a power. So this x goes out to the outside, the y goes on as an exponent of 10, so you get 10 to the y, and then the x gets pushed out to the other side equals x. Okay, that's just how I remember to do logs. So you can always rewrite logs in this form, because if the log is true, that's what this if and only if part means, then this should be true. Okay, so for instance, if we have log base 10 of, let's just say 5, let's say that's going to equal x, we don't know. So you take the x and you put it in here on the 10, so that becomes 10 to the x power equals, and then the 5 gets bumped over here to where the x was, so equals 5. And then, you know, if you could figure this out, you would, which we'll discuss a little bit later. So you can always write them in this form, and typically this form is a little easier to figure out. Okay, so that's your log of base 10. And we could have logs of other bases, but for now we're just going to talk about logs of base 10 because that's the easiest ones to deal with. Okay. Next thing we need to talk about is what we call common logarithms, or common logs, and those are logarithms to base 10. Those are the most common. That's why they call them common logs. We often write them without the 10. So if you see log of base 10 x of x, you could just write that log of x. And since the 10 is the most common, we just say, all right, well, you know, we don't really need to write the 10 anymore. It's implied that it's there. So these things are one and the same. So log of base 10 of x is the same thing as log of x. The 10 here is implied, so we don't need to write it anymore. Okay, so these are really the same thing if you have base 10, which is what we'll be talking about in this section, just to introduce logs to you. Okay, so first things first, it says evaluate the following. So log of base 10 log of base 10 of 100. Well, we could always use our calculator for this. Now we could if we wanted to, so that equals what? Well, we'll say equals x. If we wanted to rewrite this, we could say, okay, log of base 10 of 100 equals x. Remember, we take the x and we squeeze it in right here on top of the 10. So we get 10 to the x power equals, and then the 100 gets bumped over here, so equals 100. So essentially, 10 to what power gives us 100? Well, 10 squared, of course, is 100, so x must be 2. So we kind of already figured this out, but let me show you how you would use this on your calculator. Okay, so we turn it on, of course. Oh, we have some old stuff in there. Alrighty, okay, so we can use log of base 10 of 100. So our log button is this log right here, so you say log. It is implied that it is a base 10. You cannot change your bases on your calculator, and I'll show you how to deal with that when we run into it. So we just basically do log of 100. And it should give us 2. Let's see. Boom. There we go. So you just put log and then whatever you're taking it of. So we're taking the log of 100 and we get 2. Okay. So let's try the next one, and I'll show you how to do it by hand first, and then we'll come back to our calculators. So we say log of 10, or log base 10 of 5 equals what? We're going to again squeeze that x and put it right here on the 10. So we say 10 to the x power equals, and then the 5 goes this way. Okay, now, this one's a little bit more difficult because it's 10 to what power gives us 5. Well, up here we had something nice. We knew 10 went into 100, but does 10 go into 5? Not quite. So here is where we might want to back it up. Say forget about this stuff. Let's actually just use our calculator because we're not going to get a nice number. So we're just going to put this guy right into our calculator. So let's grab it here. We are already log of base 10, or just log of 5. And what do we get? I figured we would not get such a nice number. So that would be, so log of 5 is 0.698 9, 7. Okay, so let's round that to 2 places because that's all we really need. So log of 5 equals 0. Now this, we're rounded to 2, but this 8 would make the 9 go up, making the 9 go up to 7. So 0.70 is our actual answer there. So log of 5 is 0.70. And notice you might be thinking, well, wait, wasn't it log base 10 of 5? Well, of course it was, but we don't need to write the base 10 because this is our common log, so we don't really need to do that. Okay, this next one says evaluate without a calculator, so we're not going to use them as tempting as it might be. Let's go ahead and rewrite them in our exponential form. So log of base 10 of 1 million, my goodness, equals what number? Again, you take your x and you put it on your base, so we have 10 to the x power equals, and your 1 million gets bumped this way, so 1 million. Okay, so 10 to what power gives us 1 million? Well, we could actually, and here's how this works, it takes us to another step. We could always have the same base, and then we could work on what our x is going to be. So we want to write a million as a power of 10. So we write a million as a power of 10. Essentially, you count 1, 2, 3, 4, 5, 6 zeros. 10 to the 6th power should give us a million. Let's double check. So 10, oops. I know it said no calculators, but we're just using it to check. So 10 to the 6th power, does it give us a million? 1, 2, 3, 4, 5, 6 zeros. We're good to go. Okay, so we're good there. So 10 to the 6th power equals 10 to the x power, so therefore x must be 6. So we know the log of 10, log base 10 of a million is going to be 6. Okay, so actually I suppose this is really our answer. We threw the x in ourselves, so we don't want to say x equals 6. We want to say log base 10 of a million equals 6. Okay, so what power of 10 would give us a million? Well, that would be 6. Okay, now this one, it doesn't have a base, but remember, all of these common logs right now, if it doesn't have a base, you can assume it's 10. So log base 10 of 0.1 equals x. So we say, okay, x goes here, so we have 10 to the x power equals 0.1. And this one's a little bit more difficult to think about because of the decimal, I suppose. So you're thinking of 10 to what power gives you 0.1? Well, I'm going to encourage you to write these as a fraction instead. So 10 to the x power gives us, now to get this, this is 1 in the 10th place, that would be 1 divided by 10. And again, if you needed to just double check here, let's grab those calculators. Let's just check 1 divided by 10, just to be sure. 1 divided by 10, does that give us 0.1? Good, we're good. Okay, so we should know that kind of stuff, but that's all right if we don't. So if you think back to, I have something being a base here, and it's downstairs, and when it's downstairs, well, this is just 10, so this would be 10 to the 1st power. So let's go ahead and write that. This is still 10 to the x over here. Remember, to get something downstairs, you would just start with it upstairs and have that power being negative. Okay, this here is equivalent to this here. 1 over 10 to the positive 1st power is the same thing as 10 to the negative 1st power. Because remember, negatives, just put it downstairs, so this would become what we had up here. And again, if you really need to check, do 10 to the negative 1st power, and boom, we still get 0.1. So we're still using equivalencies here, we're just rewriting it in a different shape. So now that we have the same bases here, we can just say the exponents are equal. So we can get rid of the bases, just like we did up here. Get rid of the bases, and x was 6. So up here, we get rid of the bases, and x was negative 1. Okay? Which, yes, x is negative 1. That's where we put our answer. Whoops, sorry. But they wanted log of 0.1, so equals negative 1. Okay? So that's our answer. Okay. Log of the cube root of 10. Yikes. Okay, so log, and I'm just going to write that with a base 10 because I know there is a hiding base 10 down there, of the cube root of 10 equals x. Let's rewrite this in exponential form. So this guy goes on to my base. So 10 to the x power equals, and this guy gets bumped to where the x was, the cube root of 10. So I would then encourage you, instead of writing this in radical form, write this with a rational exponent so that we have exponents on either side. So we have 10 to the x, that's just 10 to the x, and then this becomes 10 to the, remember when I take the cube root, it's 10 to the 1/3 power. Okay? So now that we have the same bases, we can get rid of those and just say, oh, my exponents are equal. So then x would be 1/3. Okay? And again, they wanted the log, so we would say equals 1/3. Okay, sorry, I'm squeezing on a little bit to my work here, but our answer here is 1/3. Okay? So don't let logs freak you out. They are basically just base 10, so that you can do higher calculations without writing these higher numbers. For example, let's go back to letter A here. If we were to use the number 1,000,000, well, that's fine, but I'd have to write out 1,000,000 every time I did it. If I said it was 6 and used it in log form first, then people would know that, oh, we're log base 10, that would mean 6 zeros, so there we go. And we would know it's 1,000,000. So people actually do calculations all in logs all day long just so they can use simpler forms of these numbers. It's just kind of a way to, I guess you could think of it as like a coding, like a secret language. So don't let these freak you out. Right now they're just base 10, so it just essentially is what power of 10 would get me to this log. So kind of think of it that way. Okay, and we're actually going to pause this video and just, I'll see you in the next one, just so we make sure we have enough time here. And so then we'll work on example 3.